Leonardo da Vinci once said, "Water is the driving force of all nature." It's easy to take for granted the abundance we have on Earth, the substance without which all life cannot exist. Colonization of the Moon or Mars will be made possible through a substantial and sustainable supply of water. So far, the most reasonable option is to access subsurface ice sheets that span certain craters on Mars and the Moon. Our design is a viable solution to deliver a large volume of water in a relatively short amount of time. The Aztec Resource Extraction System, Aries, is a prototype for a rover-mounted drill similar to the Perseverance, which would also host a winch-driven infrared heater and extraction tube. The system is inspired by rod well ice drilling for a structural integrity of established extraction wells. The prototype is built from a T-slot aluminum frame on plastic sliders. It also has stepper motors and actuating screws to position and guide the drill. Our system uses a brushed rotary hammer drill and aluminum drilling flutes with a high-speed steel tip to excavate material. One drilling cycle takes approximately 40 minutes depending on the composition of overburden layers. A bar-type load cell monitors the weight on bit and triggers a pecking operation if our threshold of 130 newtons is exceeded. This allows the drill to dissipate heat and reduces the risk of damaging the flutes. Drill depth and horizontal position are monitored with LiDAR sensors and used in a feedback loop along with limit switches to monitor and control the drill position. During excavation of overburden layers, the LiDAR, RPM, weight on bit, and system current are displayed and recorded in our LabVIEW user interface and later exported for post-processing to create a digital core representing the relative hardness of each of the layers and at which depth. Once the drill is returned to its resting position, the winch begins to lower the infrared heater and hose down the hole to begin the extraction phase. A phase-fired controller is used to safely control the output of our 720-watt heater in 40-degree increments up to 700 degrees Celsius. The frame-mounted peristaltic pump operates simultaneously with the heater. Water is pulled through an inconel tube at the center of the heater and up through the hose. At the output of the pump is a two-stage filter with a 5-micron mesh, a purge valve, and activated carbon stage before collection. The highlight of our system is the custom infrared heater designed by our team and manufactured by Duratherm Processing Systems. The advantage of infrared heating is the ability to radiate deep into the ice walls and at a greater range from the heat element. This method does not rely on seed water that regenerative steam drills do in traditional rod well applications. It also does not rely on atmospheric convection, which is a slower and less effective process. The performance exceeded our expectations. We were able to extract 5.2 liters of water in 2 hours during our dry run, compared to the predicted 4.9 liters in our model. The team would like to take a moment to recognize the people that got us here today. Faculty advisors were Dr. Scott Schaefer and Dr. Saeed Menshadi, as well as support from Professor Barry Dorr and the Collins Aerospace Consulting Team, Chris Crawley, Stephen Kressler, and Che Huang.